Hello everyone, this is Mrs. Dipti Kulkarni, lecturer, Department of Physics, KLS Kokte PU College, Belgavi. In this video, I am going to discuss problems, that is last part of this second chapter, that is electrostatic potential and capacitance. So this is my 9th lecture on the same chapter. So I just taken few examples. First one, two charges 5 into 10 raised to minus 8 coulomb and minus 3 into 10 raised to minus 8 coulomb are located 16 centimeter apart. At what points on the line joining the two charges in the electric potential 0? Take the potential at infinity to be 0. Here there are two conditions. One is in between the line. Suppose if we consider the charges, two charges. Okay, so this is one charge Q1, another charge Q2. Suppose if we consider a point P between these two charges, what is the potential? And second one, take a potential at infinity, means if we consider the point P at infinity, means beyond this. Okay, suppose if we consider the point at infinity or outside this line joining, okay, where the charges are present. Now what are given data? Q1 is given 5 into 10 raised to minus 8 coulomb, Q2 is given minus 3 into 10 raised to minus 8 coulomb, and distance between the charges, two charges, that is D, 16 centimeter. If we convert that into SI, then 0.16 meter. So this is the diagram for this, suitable diagram for this problem. Okay, so these are the given factors. Now let R be the distance from Q1 to point P. So this R is nothing but what? Distance from Q1 to P. So this is the distance. Next, total potential V is equal to, we know the formula for the potential, Q divided by or 1 divided by 4 pi epsilon naught Q divided by R. So here R is required, R is missing. Okay, printing mistake. V is equal to Q1 divided by 4 pi epsilon naught R plus Q2 divided by 4 pi epsilon naught D minus R. Okay, is equal to 0. Call it as equation number 1 according to our convenience. Anyhow, this is 0, so we can consider this at LHS side and this factor at towards the RHS side. Now when we consider in that way, 4 pi epsilon naught get cancels. What is remaining? Q1 by R minus Q2 divided by D minus R. Substitute the values of Q1, Q2 and D. Okay, so Q1 is 5 into 10 raised to minus 8 and this is minus 3 into 10 raised to minus 8, but here one more negative sign is there. Already this is negative and Q2 is also negative value, so negative it becomes positive. Okay, then next 10 raised to minus 8, 10 raised to minus 8 get cancels, cross multiply 5 into 0.16 minus R is equal to minus, sorry, only 3R, not minus, only 3R. Okay, then after simplification, how much we will get? So this is not 5, this is 0.16. Okay, 5 into 0.16 minus R, same value I wrote here. Okay, is equal to 3R. Next, after simplification of this value, R is equal to 0.1 meter or 10 centimeter. Okay, so the distance between Q1 and P is 10 centimeter or 0.1 meter. Next one, suppose another case, in the same problem another case. Okay, suppose if we consider the point outside the line joining of this. Okay, if we consider point somewhere here, Q1, Q2 as it is, values are same, D value is also same. So from this Q1 to this P, Q1 to P is R1 only, distance between Q2 and P is R2. Okay. Now in the same way we have to consider the values. V is equal to Q1 divided by 4 pi epsilon naught R1 plus Q2 divided by 4 pi epsilon naught R2 is equal to 0. But here how we have considered in the previous case, similarly we have to take this one towards LHS side. Anyway here it is a 0, so that is the reason we have to take this Q2 factors in the RHS side. Now Q1 divided by 4 pi epsilon naught get cancels. What is remaining? Q1 as it is 0.16 plus R2 and Q2 minus Q2 divided by R2, right? Why here R2? Because you just carefully see what is R1 here. Is it not R1 is equal to is it not this much and R2 0.16 plus R2. So this is R1, total R1. Okay. Is it not this plus this 0.16 plus R2? So instead of R1, what I substituted here 0.16 plus R2, and here also it is R2 as it is. Okay. Next step. Substitute the values of Q1 and Q2, right? So after substitution these two get cancels. Okay. So minus 3 and due to the after converting or after exchanging the values we got negative, so for that reason negative becomes positive, right? Next, after simplification R2 value is equal to 0.24 meter and R1 is equal to, what is R1? We know that R1 is nothing but what? R1 is equal to 0.16 plus R2. So R2 how much we got? R2 is equal to 0.24 meter. After cross multiplication of the values, how much we got? R2 value 0.24 meter. Okay. Then next, after simplification we got R1 value. Okay, R1 value also. So 0.40 meter is R1 value. So this is the solution for the first problem. Next one, second problem. A spherical conductor will have a potential of 6000 volt when surrounded by an oil of dielectric constant 1.5 and charged with 5 into 10 raised to minus 8 coulomb. Calculate the radius of the spherical conductor. So what are the given data here? V is given, potential is given 6000 volt, epsilon R means dielectric constant of oil is how much? 1.5 is given. Charge is given, that is 5 into 10 raised to minus 8 coulomb, and we don't know what is the radius of the spherical conductor. R we don't know. We know the suitable formula for this. Substitute the values in this formula. 6000 and what is 1 by 4 pi epsilon naught? We know 1 by 4 pi epsilon naught is constant value, that is 9 into 10 raised to 9. We know this value, so for that reason we have to substitute, and this is misprinted. Okay. 5 into 10 raised to minus 8, that is charge value, and epsilon R is dielectric, and here dielectric of the medium, okay, epsilon R is different for different mediums. If we consider the oil or water, glass, for all these mediums values are different. So here we consider the oil and value is given, that is 1.5 R as it is. Now interchange this R. Okay. So because we don't know what is radius, after simplification substitute and simplify this. 9 into 5, that is 45, and 10 raised to minus 8 and 10 raised to 8 from this, only 110 is remaining, so 10, 1.5 as it is, 6000 here. Okay. After simplification how much we got? 0.05 meter. This is the final answer. Next one, 3 capacitances, each of capacitance 9 picofarad. Pico means 10 raised to minus 12. Okay, picofarad minus 12, right, are connected in series. Series means end to end connection. Sub question: what is the total capacitance of the combination? What is the potential difference across each capacitor if the combination is connected to a 120 volt supply? Okay, so here is the solution. Capacitance of each 3 capacitors. So this is 3 capacitors. C is equal to 9 PF for series combination. So what is the formula for the series combination? 1 by Cs is equal to 1 by C plus 1 by C plus 1 by C, because 3 capacitors are connected in series. So for that reason 1 by C plus 1 by C plus 1 by C. Okay, this is the formula for the series combination. Substitute the values of the capacitors. So how much it is? 9 for each. After substituting, simplify, 3 by 9 we will get. Okay, 3 ones are 3 threes are, so 1 by 3, or capacitance in series is 3 picofarad. This is the answer. Next, what they have asked: if suppose voltage is given 120 volt for series combination, V is equal to V1 plus V2 plus V3, but for identical capacitor. So all are identical, same values. For that reason V1 is equal to V2 is equal to V3, or V2 is equal to V3 is equal to V1. Therefore V is equal to 3V, because all are identical, 9 only, that is the reason. So we have to equate all. So 3 volt, V1 is equal to V by 3. V is how much? 120. And what is this 3? Addition of these 3. Okay, 1 plus 1 plus 1, 3. So that is 3V. Okay, so V1, so V is equal to 3V1, or V1 is equal to V by 3. Substitute the value of V, simplify, how much you will get? 40 volt. So final answer is 40 volt. Next problem. A 12 PF capacitor is connected to a 50 volt battery. How much electrostatic energy is stored in the capacitor? Here is the solution. Electrostatic energy stored in the capacitor is given by the relation E is equal to 1 by 2 CV square. Already we discussed this expression and we got this expression from the derivation. Okay, so half CV square. C is the capacitance, V is the potential. Now given data, what are the given data? V is given, that is 50, right, and capacitor value is given, how much it is? 12 picofarad. 12, substitute the values of C and V, simplify, is equal to 1.5 into 10 raised to minus 6 joule. This is very simple problem. Next one, calculate the effective capacitance between the points A and B as shown in the figure. Suppose if we consider this is point A and this is B, then all capacitors values are 1 microfarad. You just carefully see here, everywhere it is 1 mu f. Before this we have to first simplify the circuit diagram. You just carefully see, both these two are in parallel. Are they not parallel? So I just redrawn the same this diagram in this way. Okay, this is in series with this combination. So this is in series with this combination. This is in series with this combination. So this I redrawn here. Okay, now what is the parallel capacitor formula? Cp is equal to C1 plus C2. C1 plus C2, right? So Cp is equal to C1 plus C2. Substitute the value of C1 and C2, that is 1 mu f and 1 mu f. 1 plus 1 is 2 mu f. So this total answer is 2 mu f. Next, so we got here 2 mu f, okay, and 1 mu f as it is, another mu f as it is, this one as it is and this one as it is, only in the center it is 2 mu f. So that is 2 mu f, right? Again you simplify, all are in series, right? So 1 by C1 plus 1 by C2 plus 1 by C3, right? 1 by Cs is equal to 1 by C1 plus 1 by C2 plus 1 by C3. But here this is 2, so C2 value is 1 by 2. So 1 by Cs is equal to 1 by 1. This is 1 divided by C1 is 1. That is the reason 1 here. This is 2. C2 is 2. So 1 by 2. C3 is 1 again. So 1 by 1. Take the LCM and simplify. Finally how much we got? 5 by 2. So Cs is equal to 2 by 5. Okay. Ratio of this value is nothing but Cs value. So that is 2 by 5 mu f. This is a final answer for the capacitance in series combination. Next one, 3 capacitors of capacitances 2 pf, 3 pf and 4 pf are connected in parallel. All these 3 are connected in parallel. What is the total capacitance of the combination? Second one, determine the charge on each capacitor of the combination is connected to a 100 volt supply. Here is the solution. So C1 is given 2 pf, C2 is 3 pf, C3 is 4 pf. What is Cp? Very simple. Cp is equal to C1 plus C2 plus C3. This is the expression for what? For the parallel combination if 3 capacitors are connected in parallel. Okay. Substitute the values of C1, C2, C3. How much we will get? Final answer for the parallel combination of the capacitance, that is 9 pf. Next, supply voltage. If voltage is given 100 volt, then V is 100 volt, Q is equal to CV or VC. So C is equal to 2 pf, charge is equal to, means charge Q is equal to V into C. V is 100, C is 2. So total 200 pico coulomb, that is 2 into 10 raised to, after simplification of this, pico means 10 raised to, how much it is? 10 raised to minus 12 pico, but here it is 200. So 2 zeros we have to deduct it from this, so it will be 10 raised to minus 10, 2 into 10 raised to minus 10 coulomb. Okay. So I hope you understood these problems. So if you need any further questions and answers from the second chapter, please go through the link given below. Thank you.